So one of the steps we've been discussing when you build your ontologies is to reuse information from existing ontologies and datasets and integrate this information in your own one. Integration can be done at 3 levels. It can be done at a schema level through the use of vocabularies, and it can be done at instance level through the use of existing datasets, and it can also be done at both levels at the same time. When it comes to vocabularies, so integration at schema levels, there's a set of existing vocabularies that you can find already on the web. The field of knowledge representation on the web or the semantic web field is now grown up. It's about 30 years that we're working on that. And people have been working on establishing vocabularies that are very common and that can be reused across applications and across domain. The typical example is schema.org. Schema.org is actually a vocabulary, it's a very generic vocabulary that is being used by the major search engines to retrieve the most important information about certain products. When you look for a restaurant on Google and you see this small snippet on the side that says opening time and menu and location, this is all information that is created on the website through RDFA annotation using schema.org. So it's a schema that is quite useful if you are representing generic knowledge. There are vocabularies that allow you to represent, to document your ontologies. So we discussed about documenting ontologies. You can do this using the void vocabulary, using DCAD, or the doubling core. So these are mostly vocabularies that allow you to catalog certain information. You have FOF to describe people. You have SKOS that allows to describe topics that are put in certain relationship. One nice tool that you can use, one nice dataset that you can use to retrieve existing vocabularies and see whether they fit for your application is to use the linked open vocabularies website that you see over here. You can see that here the most common vocabularies are being collected. Every color is a different domain. You see what are the prefixes that these datasets use. You also see you can also see what are the what is the documentation of these datasets. You can see what are the most commonly used properties. So if you are looking for existing vocabularies, this resource is quite useful. Just a note on the use of SKOS. SKOS is a vocabulary that you will meet very often because it's less restrictive than RDF and RDFS and OWL. It comes from the digital bibliography world, where people had to represent relationships between topic in a less restrictive way than one could do with RDFS and OWL. So basically, you have a way to express a subclass of relationship which is less restrictive and more generic. And this is you can do this through the property SKOS broader. So you can say here that animals is a broader concept than birds, and it's a broader concept than mammals. SKOS broader also allows you to express meteorological information like structural information located in information membership, for example. And sometimes you will find it also to describe topic implication, like cow milk falls under the topic of cows. In SKOS, you can have concepts which are of type concepts, which have preferred and alternate labels. So the same way you have labels in RDF, RDFS, you can have them in SKOS, and you see that you have a preferred label, or it can be an alternative label. So it can be an animal or it can be a beast, but it still refers to the same concept of animals. You have symmetric relationship, SKOS related, exact match, close match, broad match. These are all properties that have been created to be able to express similarities or relatedness between topics without having to be so strict to represent them as all same as. So I want to be able to say that ornithology is related to birds, but they are obviously not the same thing. You will find these terms quite often, so make sure you know how SKOS is being used. We say the integration can be done at different levels. There's the possibility of integrating existing data sets, instances from existing data sets into your own knowledge graph. In the tutorial in class, we will look at how to do that in GraphDB. But for the moment, here is a list of, these are mostly dataset hubs. So these are buckets or website where you can go and search for a particular dataset of a particular topic. The most famous one is the link Open Data Cloud, which you see here in the picture. Where you have multiple data sets that belong to a specific domain. So every domain is an ontology. Every domain is every color is a domain, and every bubble is a data set. The edges mostly refer to whether these data sets are linked to each other through equivalent classes or same as declarations. And this also means that you could, if you decide to reuse a given ontology in the linked Open Data Cloud, you could also choose to explore it and recover information from another data set and another data set and another data set, because they're all linked. You can see that there is a couple of larger data sets in the center, which means these are the biggest ones in the cloud. This is actually not even updated. The linked Open Data Cloud is actually now much, much bigger. You do have ontology design patterns. So these are small domain ontologies that you can use. This is inspired by the design patterns in software engineering, which means if I want to represent in my dataset specific information, I can refer to the design pattern to see if other people have represented something like this, and I can reuse the entire representation. One typical example is the event ontology. An event is always structured with an actor, a location, a particular time and a particular action. So, and this can be referred as a design pattern. You do have open domain data sets that you can refer to. The most common one is the Wikipedia, but these days also Wikidata are very used. Yago is a combination. The three of them all include information from Wikipedia, and they just represent it in a different way. The difference between the three is mostly in the way they are built and maintained. You do have additional open domain datasets like NEL or ConceptNet or KBpedia. You will meet Freebase if you read about literature in the knowledge representation on the web world, but the dataset has actually been discontinued. Additionally, there's data sets which are more domain specific. So the data sets that we looked at before, they're more open domain. You do have linguistic resources, the Linguistic Lodge, WordNet, BabelNet, Framester. They specify information about concepts and how they are represented linguistically. So what are the synonyms or antonyms, meronyms? You have geonames, which is a data set representing information about geography, so capitals, subcapitals, countries. If you are interested in robotics and IoT, you have this website where you can find a lot of vocabularies around the IoT and robotics world. The biomedical world has a huge amount of data sets. Bio2RTF is actually a data set of multiple data set. You have SNOMED, which is a long-standing resource in the biomedical domain. They're still being used by companies to refer to diseases and genes and symptoms and such. You also have Mesh, Gene Ontology, Bioportal. You have resources for statistics or resources representing publications, authors, papers that are being cited, and so on and so forth. Ultimately, you might find datasets which are not in an RDF format, but they can be imported, so they are semi-structured in a sense. And here you have examples for images, for music, for question answering, sentiment analysis, and a number of other sources. So all these are resources that you can use, but you would have to process the information from there and transform it into an RDF format before importing it into your own dataset. We will do this as part of the lab, so you don't have to worry about how to do that now. Thank you.